I've got this curve r equals 2 secant theta. Which graph is this curve a graph of? Which one does it match up with? If you have r equals 2 secant theta, it doesn't really mean anything to you, but can I manipulate this in a way that might be meaningful to me? What is secant theta really equal to anyway? 1 over cosine theta, right? All right, if I have r is equal to 2 over cosine theta, what can I do with this? If I cross multiply it, what do I get? R cosine theta is equal to 2. And what is r cosine theta anyway? What's another word for it? It's x equals 2, right? So which graph actually represents x equals 2? D. This is x equals 2. This is x equals negative 2. A lot of students get this one confused. This one is not x equals 2. This one is y equals 2. Over here, you've got a diameter of 2, and this is straddling the x-axis, this circle. So this is going to be an r equals 2 cosine theta curve, and this one right here is going to be an r equals, this is a diameter of 2 straddling the y-axis. So this is an r equals 2 sine theta curve. All right, any questions?
Talk about is if you have a Cartesian plane, an xy Cartesian plane, and you wanted the area under the curve of f of x, okay? How did you find that area under the curve from, let's say, from x1 to x2, okay? You did the area, the integral, okay? But step by step, okay, what we did was we just took a little delta x, right? And we said, okay, if I took a little delta x, this is delta x, the area of this rectangle, okay, was delta x times f of x, right? And that what I did was I incremented that delta x. I added another delta x to it and another delta x f of x. But this f of x changes with time, right? So I had to say this plus delta x plus this plus delta x. Okay, you added a whole bunch of them together. These delta x's, these f of x changed with time. And so then I added them all together, and so that was a sum of f of x delta x, okay? And then I said, well, I don't want an estimate. I don't want like the Riemann sum estimate of the area under the curve. I actually want the real stuff. I want the real area under the curve. Okay, so let me highlight this to make sure we're both finding the same thing. I'm trying to find the area under the curve from x1 to x2. So this area here, okay? And so what that became was I wanted to take the delta x and I wanted to take the limit as the delta x went to 0, right? As these rectangles got smaller and smaller and smaller, then the actual area under the curve was the integral of f of x dx. Everyone good with that? Okay. Now I want to point out that when you did this, okay, what you did was actually, you may not really thought you did this, but you actually went from the smallest x to the biggest x, and you actually assumed that y was 0, and you shot up. You said, okay, y is the value here. And you moved over, and you shot up, and you said y was a value here. And you came over, and you shot up, and you said y was a value here. So it was a lot like Space Invaders, right? You guys play Space Invaders, right? You move over, and you just shoot up, okay? And this was like the f of x. You shot up to your f of x, okay? So we're going to do something similar today, okay? But it's not going to be Space Invaders anymore. What we're going to do is we're going to find the area of a polar region, okay? And polar regions, instead of f of x, you know, here you have f of x equals something, right? X cubed plus 2x minus 3 or something. Over here, you have r equals something, right? R equals 2 cosine theta or something like that. And so over here, your r is your limiting function over here. This is your r. It's r with respect to theta. This was f with respect to x, okay? And so over here, what you did was you started and you incremented in delta x's. Over here, what you're going to do, okay, let me put some dotted lines here. So these are my dotted lines. Like I want to go from theta 1 to theta 2, okay? And I want to know the area in this curve. So let me highlight this area just to make sure we're understanding the same thing. I want to know this area here, the area between theta 1 and theta 2 for this boundary R. So same kind of concept, right? But now, instead of incrementing delta x's, I'm going to increment delta thetas, okay? So if I wanted the area of just one of these little sections of pies, and you understand, because R varies, every section is not the same, just like over here, because f of x varied, every section was not the same. What is the area of one of these sectors? Okay, well, think about in pre-calculus, when you wanted an area of a sector of a circle, okay, if you wanted this area right here, do you remember how you got this area? Over here, this rectangle, it was f of x times delta x, right? It was a rectangle. It was basically b times h. Over here, what's the formula for area of a sector? Well, what's the area of the whole circle? Isn't that pi r squared? Well, what if I told you that this was 30 degrees? Then you did 30 degrees divided by 360, right? You did the fraction of it, right? But in calculus, we're no longer in degree land. So this 360 would be what? 2 pi. And this 30 degrees is whatever angle you're talking about, the amount of your angle here, okay? So this new formula actually is now your angle times pi r squared over 2 pi. But do you see your pi's cancel out? So your formula here is 1/2 theta r squared. Do you remember that area formula for area of a sector in pre-calculus? Okay, so we're going to do the same thing. So this area right here is going to be, let me do it in blue. This area right here is going to be 1/2 r squared times delta theta. Does that make sense? Because this theta here is just a delta theta. Then I'm going to add another one. I'm going to add another 1/2 r squared times delta theta. I'm going to add a whole bunch of them. Does that make sense? A whole bunch of these pie-shaped things. And when I sum them all up, when I sum up all of my 1/2 r squared delta thetas plus 1/2 r squared delta thetas, and I get a whole bunch of them, and I sum them up, if I wanted the exact area of this region, what I would do is take the limit as delta theta goes to what? 0, right? So this becomes, the area of a polar curve becomes 1/2, you can pull out the 1/2 because it's a scalar, r squared d theta, and that's the formula you're going to memorize, okay? And that should be the formula that's on top of your worksheet. Now I need to talk about this formula, okay? Because even though this formula is easy to remember, okay? I can't tell you how many times on the test, about like 5 students on the test every year will say, oh, area of a polar curve, integral r d theta. Where did you get that from? Yeah, your rear end, basically. There is no formula like this, okay? You can't just make up a formula. You can't just say, oh, this one's like your f, this one's like your x, so r d theta, okay? You cannot make that up, okay? So notice this formula, if you're looking at polar curves, okay, something that I forget a lot also is that you have a 1/2 here, okay? You have an r, not just an r, you have an r squared here, okay? And if this is d theta, then what are my limits going to be? Theta 1 and theta 2, okay? The other thing that students do wrong is they throw a pi in here. Do you see a pi in here? There is no pi in here. I think the reason students throw a pi in is because you get it confused with this formula. I'm guessing. Does that make sense? And you have to memorize all your formulas. So these are 2 totally different formulas. This is polar, this is Cartesian. I mean, there's lots of different things about these formulas, okay? All right, so let's go ahead and look at your notes, and let's talk about how we're going to calculate this. Oh, this is what I need to tell you, the magic windshield wiper. Okay, so just like this over here was your Space Invaders, okay? So it's a Space Invaders game. You came up and you shot up, okay? This one over here, okay, is like a magic windshield wiper, okay? Because you have to stand here at r equals 0, just like you had to stand y equals 0. But unlike the Space Invaders game, your y equals 0, you would move forward as your angle increased, okay? But in a polar graph, as your angle increases, you know angle increases this way, right? You stand in one place. You don't move, Okay, r equals 0 here, r is still here, r equals 0 here, r is still equal to 0 here. It's always here no matter what your angle is. Okay, you stand here and you're going to punch out. You're going to punch out like this, but when you punch out, there are different distance that you punch out at because your r varies. All right, so this is like a magic windshield wiper. You can think about that like that, right? That's how your windshield wiper works, kind of, except this one's a punching out one. Okay, so someone make up that game. Okay, that would be a great game. All right, so magic windshield wiper. Okay, let's look at one other thing I want to talk to you guys about. Okay, when you do your integration, okay, when you do your integration, the hardest thing to do is going to be to get your limit. Okay, part of it is understanding what you need to do, and the other part is really just even if you understand it, just finding the limits. Okay, so I want you to think about when you have an integral of f of x dx. Okay, and you found the area under the curve. Remember that you always wanted this number to be smaller than this number. I mean, you wanted to try that as much as you could because that was intuitively how you figured out the area under the curve. Okay. On a circle, it's even more important because if you think about how a circle acts, this is like 0 here. Okay. If I wanted the area of this pink region, and I told you that this was pi over 6, and I told you that this was 11 pi over 6. Well, actually, I'll probably say 11 pi over 6. Do you agree that this is 30 degrees this way and 30 degrees this way? Okay. If I actually do the integral from 11 pi over 6 to pi over 6, I'm actually not getting what I think I'm getting. Because 11 pi over 6 is really, isn't that 330 degrees? And this is really 30 degrees, right? So what I'm doing is I'm going from 330 degrees to 30 degrees, okay? And if you think about that on a number line, okay, I'm actually going like backward. I'm doing a giant thing. I'm actually getting the negative of this angle, if this makes any sense. I'm actually not getting this angle here. Okay, so what you need to do is make sure that you're going in order. Like your number down here should not be 11 pi over 6. Any idea what it should be? Because it needs to be smaller than 30 degrees. Negative pi over 6 or negative 30 degrees, if that makes any sense. Okay, then you'll be getting the angle that you want here. Okay, that's super important in polar. And so what I want to point out to you guys, and I think you know this, but we don't talk about it a lot. Okay, so I need to have that talk with you, and that is this. When we talk about the unit circle, we'll put negative pi over 6 here, and we'll say that that is the same as 11 pi over 6. But that's actually not true. There's not an equal sign there, right? Negative pi over 6 is not equal to 11 pi over 6. However, sine of negative pi over 6 is equal to the sine of 11 pi over 6, right? And the cosine of negative pi over 6 is equal to the cosine of 11 pi over 6, all right? And so we always acted like they were the same, but they're not the same. They're actually totally different values, one much bigger than the other. But their sine and their cosine values are the same, and that's why we have a unit circle, okay? All right, so that's a long lecture for something that I think you know, but you could be confused with. All right, so let's go ahead and look at your notes. This is the first problem. Go ahead and graph this problem. I know you're good at it, okay? Go ahead and graph this problem. Did you guys pick up your notes? They're up here if you don't have it. And I'm going to put in a 0 first, and this will be a 2. Then I'm going to put in a pi, and sine of pi, oh, I'm going to put in pi over 2, right? Sorry, sine of pi over 2 is 1, so this is going to be 4, 1, 2, 3, 4. I'm going to put in a pi. Sine of pi is 0, this is going to be 2. Is that right? Wait a minute. Sine of pi is 0, yeah, so that's going to be 2. And if I put in 3 pi over 2, that's going to be negative 1, so this will be 0. All right. I know what kind of picture this is because this number matches with this number, so what kind of picture will it be? A heart, a cardioid. So I'm going to use where the 0 is to do my sharp turn, and I'm going to draw, I'll draw my heart, okay? The nice thing about the heart and the limasomes, the cardioids and the limasomes, theta R, is that it makes a full period, okay, from 0 to 2 pi. So you can just memorize that. For cardioids and limbozones, it's always 0 to 2 pi if you want to get the area of it, okay? So what we're going to do is we're going to find the area of this cardioid, okay? And the area is 1/2 r squared d theta, okay? And that's equal to 1/2 my r squared, okay, r is 2 plus 2 sine theta, so I take the quantity squared, and let's go find the thetas, okay? This is super easy. I just go from 0 to 2 pi, okay? They're not always this easy. This one's easy because this thing makes a full circle from 0 to 2 pi. Now, I need to make sure you understand what we're doing, though. When I say 0 to 2 pi, what I'm saying is first you start right here, right? This is at 0 degrees, and you punch out, okay? And as you punch out, okay, I'm sweeping the area. Do you guys see that? So I'm sweeping the area from 0, and I'm going up to pi over 2. I'm going around, okay? I'm sweeping, and I'm basically plotting all of these points, okay? And as I plot them, I'm sweeping this, okay? And so what it is, it's a sweep. So if you think about your arm there, everything that this thing sweeps, I'm covering all of that area, okay? There's nothing that I leave out. I'm covering all of that area. And I'm sitting at the pole, and as I sweep all the way around, I find that I make a complete circle when I go to 2 pi. Okay, so that's why this is from 0 to 2 pi. Okay, so this is going to be 1/2 0 to 2 pi. What is 2 plus 2 sine theta quantity squared? Is it 4 plus 4 sine squared theta? No. It's got a middle child. Okay? So go ahead and write that down. We're following that. It's got a middle child. Don't forget the middle child. Okay, so what you're going to have to do is integrate this by hand. You have a question on your test. You have to integrate this by hand. I don't remember if it's 1 or 2. Okay? And so let's think about this. Are you guys okay if I take out the 4 first? I'm going to take out the 4 because it's going to make my integration easier. Okay, remember, integration is the hardest part. So if you can do anything to make it easier, go ahead and do that. So I'm going to take out the 4. So what I get is 1 plus 2 sine theta plus sine squared theta d theta. Okay, let's see what I have. Can you integrate this by hand? What's the integral of 1? Theta. What's the integral of 2 sine theta? Negative 2 cosine theta. Okay, what's the integral of sine squared theta? You have to do something. You have to change it to something. What do you have to change it to? Remember the sine squared thetas? So this is A is equal to 2 times 0 to 2 pi of 1 plus 2 sine theta. And anytime you have sine squared or cosine squared, you have to use that formula. I think it's minus. 1 minus cosine 2 theta all over 2 d theta. Okay, are you guys comfortable with that? If you're not, you got to get comfortable with it, okay? So now, when I have a sine squared, I change it to this because I've memorized that formula. And this is going to break up. So the new, I'm going to break this up into 2 fractions. So this will be 1/2 minus cosine 2 theta over 2 d theta. And the reason I'm going to break that up is because these will add together right here. Now, you don't have to break it up, okay? But it's a lot, well, you have to break it up, but you don't have to add these together. But it's a lot easier if you add these together. So this would be 2 from 0 to 2 pi, 3/2 plus 2 sine theta minus cosine 2 theta over 2 d theta. Okay, are you guys with me so far? And I have to admit, not everyone sees that you have to add this 1 and the 1/2. And if you don't, you'll get the exact same answer. So it's not a big deal if you don't add the 1 and 1/2. But for sure, you need to break up this fraction, okay, into 2 fractions. All right, let's go ahead and integrate. You guys ready? What's the integral of 3/2? 3/2 theta. What's the integral of 2 sine theta? Negative 2 cosine theta. What's the integral of cosine u? Sine u divided by the derivative of u, which is 2. But 2 times 2 is just 4. Okay? So this is what I have. When I'm done with this first fundamental theorem of calculus part here, the win bar, then I'll just multiply by 2 when I'm done. All right? So what do I do next? Yeah, you plug in. Okay, so first plug in your 2 pi. So this will be 3 halves times 2 pi. Oops, I'm trying to change the color here. Minus 2 cosine 2 pi minus sine 4 pi over 4. So first you plug in the 2 pi, then you plug in the 0. So if you plug in the 0, I have 0 minus, be careful guys, 2 cosine 0, okay, is not 0, minus 0. Okay, then you slap a minus sign between. Make sure it's minus this entire quantity. And when you're done, you're going to multiply this by 2. Okay, and please be neat on your paper. Okay, those of you guys who are all over the place on your paper. You know how, like, sometimes when I look at your paper, it reminds me, like, you know, when you first write your name, you're like, T-I-M, like this is how my son did it, O-T-H-Y. There's my, you know how when you first write your name, like you don't write anything in order? Sometimes when I'm grading your test, that's what I feel like you guys are doing, okay? Guys, start from the left, okay? We're not in Chinese school. You start from the left, okay? You go right, okay? And you come down on your paper. Don't go up on your paper, okay? All right, so this is going to be 3 halves times 2 pi, which is 3 pi. What's the cosine of 2 pi? Is that 1 or negative 1? 1. Okay, so this is just minus 2. What's the sine of 4 pi? 0. Okay, so nothing to write there. What's negative? Okay, well, what's cosine 0 here? 1. So it's negative negative 2 plus 2. Okay, so did you get 6 pi? And that is the answer. That is the area inside this cardioid, 6 pi. Kind of cool if you think about it. You just found the area. Now notice, the answer has a pi, but did your equation start out with a pi? No. Okay, so the pi came from the limit. All right, so make sure you don't just throw a pi in there. All right, let's do another problem. Oh, let's talk about this first. Okay, I'll put the slide up so you can look at it and remember it. But this is really important because the limits are the hardest thing to figure out, those angle limits. If you have a cardioid or a limosone, it's always going to be 0 to 2 pi. So those are actually, even though they're terrible to draw, those are actually the easiest to get for the limits, all right? If you have a circle with the center not equal to 0, so kind of like r equals 2 cosine theta or r equals 4 sine theta, okay, those circles that are on your discovery sheet, okay, that period just goes from 0 to pi. Even though you think it's 0 to 2 pi, it's not. Even though it's a circle, it's 0 to pi. The circles go to 2 pi when you have something that's just like r equals 5. Does that make sense? When it's just a number. And the center is 0, 0. Okay, that's when you have 0 to 2 pi, okay, on your limits. Whenever you have a pedal, okay, so that means if you have a rose or a limit gate, we count the limit gate as a pedal, even though it's a skater. And even the inner loop of a limosone, you know what the inner loop of a limosone is? Like the inner loop right here, we count that as a pedal. Whenever you have a pedal, the way you find your thetas is actually to set r equal to 0. And we'll talk about that in a second, okay? And then finally, if you wanted the area of a limosone with an inner loop, if it has an inner loop, you actually have to subtract the area of an inner loop, and we'll talk about that in a second too. So you may not totally get that right now. Let's go ahead and look at this problem here, your second problem. Let's go ahead and graph it or sketch it. It looks like a circle, but it's got a 3 theta. What's that 3 theta tell me? It's a rose. How many petals does it have? 3. So it has 3 petals. Where is the first petal? First quadrant, because it's a sign problem. How long is that first petal? 2. So go ahead and draw a first petal in the first quadrant, and it should have a length of 2. I only need 1 petal. Okay, this one only says 1 petal. But had I needed more, I would just take that area and multiply it by 3. You agree if I wanted the whole rose, okay? But this one is only asking for 1 petal. All right, so let's start 1 petal at a time. The area of this petal is going to be 1/2 the integral of r squared d theta. Are you good with the formula? Okay, so this is going to be equal to 1/2. R is actually 2 sine 3 theta. So this is going to be 4 sine squared 3 theta d theta. Are you good with squaring r? Okay, now all we have to do is find the limits. Now let's think about what the limits are, okay? What I want to do is sweep this petal. So if you think about what I want to do, I actually want to, remember it's a magic windshield wiper, I always start from the pole. So here's my pole, okay? I'm going to sweep this petal to get the area of it. Do you agree? So what I need to know is at what angle do I start the sweep and what angle do I stop the sweep, okay? And guys, don't just guess, okay? Like some students are like, pi over 6. Okay, like you can't do that. I'm just letting you know, okay? So what you do is you do it scientifically. Think about it. When do I start drawing my petal? Where am I at when I start drawing my petal? At r equals 0, right? And then r has a bunch of numbers, and you guys did this when you plotted. Then you plotted all different values of r, and when you finish plotting your petal, what was your last value of r? R equals 0 again. Okay, so that's the secret. They're kind of like x-intercepts, if you get that, okay? So what you do is you find the x-intercept by setting r equal to 0. Anytime you have a petal, just do it. Actually, if you don't even understand this, okay, if you have a petal, just set r equal to 0. So what I'm going to do to find my thetas is I'm going to set r equal to 0. So I have 2 sine 3 theta is equal to 0. All right. Students get stuck right here. Guys, my goal is to find theta. What do I do first? Divide by 2. Okay, you need to get rid of this 2. So you want to try to isolate that theta. So all I get is sine 3 theta is equal to 0. What this is this angle right here, okay, is equal to, okay, some angle. Like what is this number right here, this 3 theta is equal to some angle, okay? And it's an angle when my sine value is 0, right? Usually I would say theta is equal to something, but right here I have 3 theta. So I'm going to say 3 theta is equal to some angles. Which angles? It's an angles when my sine value is 0. So what angles are those? 0, what else? Pi, what else? 2 pi. And I'm going to suppose, and you tell me if this is wrong, can I also say that there's a negative pi here? Right? Okay, so I'm going to give that to you because sometimes, maybe not in this problem, but sometimes I might want to go from here to here. Does that make sense? I might want to be in the 4th quadrant. And if I want to start from the 4th quadrant, I need to get that negative in there. All right. It turns out if you have a sine, you don't need that negative. But if it's a cosine problem, okay, because it straddles this 4th quadrant and the 1st quadrant, you'll need the negative there. Okay, so let's go ahead and find our theta. Negative pi over 3, 0 divided by 3, pi divided by 3, 2 pi divided by 3. Okay, we knew our 3 theta, but that's not what we were looking for. We were looking for our theta. All right, now here's where your smarts comes in. You got to pick 2 angles, okay, that would work for this petal. And think quadrants. This is in the 1st quadrant. So which 2 numbers are you going to use? 0 and pi over 3. And that's what you're going to put here, 0 and pi over 3. And that is the hardest part of all of these problems. Actually, not super hard if you just mechanically do it. If you understand, look, set r equal to 0, solve for theta, find the thetas that's in the right quadrant. That's really all you do, okay? All right, so we've got 0 to pi over 3. And I'm going to set this up for you, do part of it, and then I'll leave you guys on your own. Okay, so this will be from 0 to pi over 3. This is going to be, let me pull out the 4, okay? If I pull out the 4, I'll get 2 from 0 to pi over 3, okay? Sine squared 3 theta, I'm going to have to use that formula that I know. So that's 1 minus cosine, is it 6 theta? That's a 3 theta, right? So this should be 6 theta, all divided by 6? No, by 2. Okay, that's the formula. All right, so 1 minus cosine 6 theta. And then you guys tell me what you would do next. Do you guys see a scalar you could pull out? Yeah, I would pull out this 1/2. I think whenever you see a scalar, as long as it's 1/2 throughout the whole integrand, you can pull it out. So what you get here is 0 to pi over 3, 1 minus cosine 6 theta d theta, okay? You have to do these by hand, so just FYI. Let's go ahead and take the integral of this. These are actually, it's a buy one, get one free problem. So the integral of 1 is what? Theta. What's the integral of cosine 6 theta? Sine 6 theta divided by 6, okay? This will go from 0 to pi over 3, okay? And then I'm going to let you guys plug in, but then you get your answer after you plug in, okay? All right, I'll tell you the answer if I can find it here, and you guys can check your answer when you're done. I don't know the answer. Sorry. Is it pi over 3? Yep, it's pi over 3 for one petal error. Very good. If you wanted the whole rows, you multiply that by 3 and you get pi if you want the whole rows. Okay, let's look at your next problem. R equals 4 cosine 2 theta. Let's talk this through. What kind of problem is this? What kind of picture is it? Rows. Okay, how many petals? 4. Okay, so let me write that down. 4 petals. Okay, I know it says just one petal, but just a note, sometimes you have to find the whole rows. Okay, this is a 2, so guys, when it's even, you have to double the number to get the petals. Where is my first petal going to be at? Straddling the x-axis. How long is that petal going to be? Okay, 4. So go ahead and draw that. Your first petal has a length of 4 and straddling the x-axis. Super important because that's going to help you find your limits. All right, so let's go ahead and set this up. The area is equal to 1/2 the integral of r squared d theta. Write the formula first, okay? Write the correct formula first. Don't make up your own formula. R squared is actually 16 cosine squared 2 theta d theta, okay? Now don't pull out the 16 yet because I'm going to show you some kind of cool things we can do with this problem. First, I need to find the limits. If this is a theta, I need to go from theta 1 to theta 2, okay? So think of this as this. Do you see as you plot this thing, do you see that your theta 1 is somewhere here and your theta 2 is somewhere here? Okay, sometimes you're surprised actually because sometimes your theta 1 might be like 3 pi over 2. But no matter what, it's in the fourth quadrant and the first quadrant. You good with that? Okay. So how do I find where my petal starts and where my petal stops? How do I find that? Set R equal to 0. Always, always. Actually, if you have a petal, just set your R equals 0. Maybe you'll get some partial credit. Okay. So you get 4 cosine 2 theta equals 0. That means cosine 2 theta is equal to 0. Okay. That means this 2 theta, we used to just have theta here, but now it's 2 theta. That means this 2 theta is equal to, at what angle is my cosine value 0? Think about it. Pi over 2, where else? 3 pi over 2, and can we go backwards for me? If I went backwards, what would that angle be? Negative pi over 2. And this negative pi over 2 is super important when you have these cosine problems, when you have this thing straddling. You guys can see why, right? Because you actually need a negative angle and a positive angle, okay? So that's why you need it for your cosine problems, all right? Now be careful, this is not what my theta is equal to. This is what 2 theta is equal to. So I need to go through and divide every single problem by 2 to figure out what my theta is equal to. Okay, so these are all my possible thetas, all right? Look at my picture. This is where my smarts comes in. Look at my picture. Which 2 thetas am I going to pick? Where one is in the fourth quadrant and one is in the first quadrant. They have to be in order, so small to big. Which 2 am I going to pick? Yeah, the negative pi over 4 and the pi over 4. So put that right here. These are your limits. The limits is the hardest thing to do, but you need to go home and practice these, okay, and figure out why it's the way it is, okay? So this is negative pi over 4 and 2 pi over 4. Okay, I'm going to show you something kind of cool. Do you see that if you had to do these limits, if you had to plug in these limits, that plugging in the pi over 4, I could probably do it. I don't like it, but I could do it. But plugging in the negative pi over 4, not as easy, but you could do it, okay? What could I do with symmetry that would make this kind of nice? Yeah, split it up. Watch this, guys. See this right here? This, because of symmetry, this area is going to be the same as this area. Okay, and you can only do this for your the ones that straddle your x's. Okay, but what's nice is if I change this to 0, then I just multiply everything by what? 2, right? Now, and this turns out to be 1. Do you guys see how that works? Now, you don't have to do that. You can totally leave it like I had it and solve it that way. It would just take you longer. Okay, so my new problem is the area is equal to 0 to pi over 4, because that 2 canceled out, 16 times cosine squared 2 theta d theta. Okay? I would pull the 16 out, okay, and then rewrite this problem so that I could actually solve this as the integral of 1, would it be plus or minus? This is a cosine squared, plus cosine 2 theta divided by 2 d theta. And the nice thing about these area polar problems is, used to when you had special integration, you were worried about how do I integrate cosine squared 2 theta. Well, now that's the easy part of the problem. Okay, now I gave you other things to worry about. So that's cool. You got other things to worry about. Okay, this part right now is easy, the cosine squared 2 theta. Okay, how would you integrate this? What are you going to divide? Well, you guys okay if I pull the scalar out? Oh, did I do something wrong? Oh, yeah, you're right. See, I still have to worry about that special integration. Okay, this should totally be 4 theta. Okay, should I redo that? You guys okay? You guys are okay. All right, what would you do next? Yeah, I would pull out the 2 just so the integration is a little bit easier. So this is going to be 8 times the integral from 0 to pi over 4 of 1 plus cosine 4 theta. Okay, I'm going to pull it down a little bit more for you, then I'm going to let you guys go. This is going to be 8 times, what's the integral of 1 theta? What's the integral of cosine 4 theta? Sine 4 theta divided by 4, and we'll take this from 0 to pi over 4. Okay, I'm going to leave you guys there. First, you're going to plug in the pi over 4, then you're going to plug in the 0, then you're going to slap a minus sign between, and when you're done with that, multiply by 8. Okay, and your answer should be, did anybody get an answer yet? 2 pi. And if you had the whole rows, because you've got 4 petals, it would be 8 pi. All right? Okay, let's look at number 6 and 7 on your homework. So pull out your homework, please. Let's look at number 6. And number 6, you had a problem, I think, that looked like this. Can you guys correct me if I'm wrong, because I'm about to sketch it. Number 6, if I put in 0, I got 3. If I put in 3 pi over 2, I got 1. If I put in pi, I get negative 1. And if I put in 3 pi over 2, I'll get 1. Okay, so your picture was, oops. Can you guys check your picture number 6? Was the inner loop something like that? Okay, so what they're asking you to do first is just find the area of this inner loop, okay? The petal. This is what they call a petal. It's really just the inner loop. Okay, so find the area of the inner loop. Okay, guys, treat it like a petal. Where does a petal start and where does a petal stop? Okay, treat it like a petal. So let's think about this. The area is going to be 1/2 r squared d theta, okay? Same thing. My r, I've already gotten. It's 1 plus 2 cosine theta quantity squared d theta. I'm already halfway done setting up the problem, okay? I just need to know where the petal starts and where the petal stops. How do I figure that out? R equal to 0, okay? So go up to your R, set your R equal to 0. What you'll get is 2 cosine theta is equal to negative 1. So therefore, cosine theta is equal to negative 1/2. So guys, where on my unit circle is my cosine value equal to negative 1/2? At what 2 angles? Think about that. Is it 2 pi over 3? What's this one? Is it 4 or 5? I think this one's 4 and then this one's 5. Okay, so it's 4 pi over 3. All right, so guys, does that match with this though? This starts at 2 pi over 3 and stops at 4 pi over 3. Does it? Do you remember when you sketched your Lima song? When you sketched it, you plotted this point, then 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 this point. And when you got here, you got r equals 0. Do you remember that? And then when you started plotting these points back here, what were you doing? Do you remember? You were stepping backwards. Do you remember? When you had 2 pi over 3, you got 0. But then when you went to the next one, you started stepping backwards, okay? And guys, that's why this inner loop, okay, is bounded by 2 pi over 3 to 4 pi over 3. Okay, it's because you're walking backwards. And when you got to this point, you got to 4 pi over 3. Okay, so this right here is from 2 pi over 3 to 4 pi over 3 because your petal was formed when you were walking backwards from those angles. Okay, and so if you go look at your, that staple worksheet where you had to plot all those T-charts, you'll see when you did an inner loop, that's what you did for the inner loops. Okay, and so I set that up for you. This is your setup for number 6. Okay, so here's another question. What happens, because number 7, they want you to find something else. What happens if you want not to find the area of this inner loop, but instead you want to find the area of between the loops? So this is number 7. Okay, is everybody good on the area that I'm trying to find? Okay, this is really tricky because it has a lot to do with how the windshield wiper works. Okay, so let me enlarge it for you, see if this makes any sense. Okay, this is the inner loop. This is my x-axis. Okay, this is my x-axis. Now, when I start punching my windshield wiper, let's think about this. Okay, when I punch my windshield wiper, let me get a highlighter. Maybe it'll be easier with a highlighter. When I start punching at 0 degrees, here I am, right? And then I punch, and then I punch. Well, do you guys see when I originally start punching out here, okay, do you see I've covered my inner loop? I've covered the area for my inner loop. So if I go from 0 to 2 pi, I've actually already done half of my limosome. Even though I never drew my inner loop yet, I haven't drawn my inner loop, I've already like swept half of the limosome from 0 to 2 pi, okay? And then if I keep sweeping, okay, if I keep sweeping from here, okay, here at 2 pi, I'm going to start drawing this thing, right? So when I draw this thing, I'm going to actually start sweeping this bottom part, which hasn't been swept before. But wait, what happens after I hit this point? Then I'm going to start sweeping here, which I've already swept before. You guys see that? I've already swept this before, okay? And then what happens after this point? Then I start sweeping here, right? So let me get my highlighter back out, okay? I'm going to sweep. I want to do a different color, sorry. So I'm going to sweep, I'm going to sweep here, right? Okay, and these parts I haven't swept yet. But hey, wait a minute. What happens when I sweep right here? Do you see I'm double sweeping this inner loop, which I've already swept once, okay? So it's kind of interesting. When I go from 0 to 2 pi on an inner loop, on a limosome with an inner loop, okay, I actually sweep this loop how many times? Twice. I've actually swept the inner loop twice. So if you ever want to find the area of just this outside, how many inner loops do you have to subtract? 2 inner loops. Okay, so number 7, the way you do that is you'd go from 0 to 2 pi of your r squared. So I don't remember what your r squared is. Is this it? Okay, that's going to be the whole thing, but it has 2 inner loops inside it. So you need to subtract 2, oops, sorry, this is 1/2. I forgot the 1/2. 1/2 of this minus 2 times 1/2 of the inner loop. And we said from the inner loop, that was number 6, right? We went from 2 pi over 3 to 4 pi over 3. Okay, I've run out of room, but this is your r squared d theta. You just copy your r squared here. It's the same r squared. Okay, this number right here is your answer to problem number 6. Does that make sense? If you take your problem number 6, put it here, multiply it by 2, that's 2 of the areas here. And if you subtract it from the whole, from the whole inner loop thing area from 0 to 2 pi, that would be this region here on the outside. Okay, the region that they asked you to find was actually this region here that's highlighted on the outside. Okay, now this just looks like a star that burst. Right? It makes no sense probably, but okay, you're just trying to find this yellow highlighted area. Okay, what if I said, hey, I just want the area of this limosome, this inner loop limosome. do you see you would have to take this and subtract one of the inner loops, right? And subtract one of the inner loops. If I just wanted this area right here, if I wanted the area of this thing, I have to subtract one inner loop because I got two inner loops when I did the windshield wiper, the magic windshield wiper. Does that make sense to you guys? Okay. Well, if it doesn't, that's why number 7 is optional. Okay. But that's why we have to subtract two of the inner loops for number 7. All right. Good luck on your homework.